Okay, so with D, okay, you might think then that we're going to just use this rule again, yeah, because we've got a linear bracket here, and you might just think, well, if we take it up, we can apply the same rule. However, we have a problem, don't we, if we do that, because let me just show you. If I have this here, okay, well, if I take it up, well, at the moment that's like the power 1, isn't it? Because there's no bracket there, so you can put a bracket around the power 1. And if I take it up, it'll become -1, yeah? And then if we employ this rule, where we add 1 to this, well, you're going to get 0, aren't you? If I add 1 to that and I get 0, anything to the power 0 will just be 1. So the whole thing vanishes, okay? And of course you're going to be dividing by 0 then, okay, which is not allowed, okay? So that method doesn't work when you have a linear term on the bottom and the bracket there would be to the power 1. So if you remember, what we've got to do is we've got to use the ln function, yeah? So we just need to remember that if we've got to integrate 1 over x dx, that just becomes ln x, okay? Of course, plus a constant, where we've got a linear term on the bottom, okay? Now, it can be applied to this as well. So what you do here is, if you've got a number on the top that is 1, so in this case it's 2, okay, we'll put that to start with. And then if you've got a number in front of the x, okay, in this case it's 3, we put that on the bottom. Okay, so you see what's on top, you see what's in front of the x, which is 3 in this case, and then you write your ln, and then in bracket then 1 plus 3x, okay, plus a constant, and we're done. So it really is that simple. With E, we've got to integrate here, okay, cos 2x dx, okay. Well, you just need to remember that the integral of cos x dx is quite simply sine x, okay. And you can do the reverse, can't you? Because if you differentiate sine x, you should get cos x, which you do, okay. So you can always reverse the process to see if this is right here. Of course, a constant there. Now, when you've got cos of 2x, okay, similar sort of pattern as we've seen before with the brackets. Okay, so this will become sine of 2x when you integrate it, but then you've got to then divide by the derivative of this here, okay, because this is like sine of 2x. So differentiate 2x, you get 2. So the answer to that will be sine 2x over 2 plus constant. So with f then, we've got the integral of sine 3x plus pi. Now, in this case here, that literally does mean the number pi, right? 3.14, etc., etc. Okay, so don't worry about it, it's just a constant in this bracket. So we need to remember then, just like we need to remember here, we need to remember the integral of sine x dx. Well, sine x, the integral of it is minus cos x. Okay, and again, just think about if you differentiate this, you'll get to sine x, won't you? Because when you differentiate cos x, it's minus sine x. So when you differentiate minus cos x, it'll be sine x. Okay, so when you're integrating sine x here, you should get that sort of result. Now we're integrating sine 3x plus pi. So this will be minus cos 3x plus pi, okay, divided by then, you've got to differentiate in here, right, and that's just going to become 3, because 3x becomes 3, pi is just a constant, so it differentiates to be 0. Don't forget then to put the c on the end. Okay, with g, you've got the integral of e to the 4x plus 1, okay, well, again, you need to remember what the integral of e to the x is to start with. So e to the x, it's simple, isn't it? E to the x with respect to x just becomes e to the x. Okay? It doesn't change when you integrate it, plus a constant. So same going to apply here. Integrate e to the 4x plus 1, it just becomes e to the 4x plus 1. Okay? But remember that you've got to divide, because this is like a function of a function, you've got to divide by the derivative in here, which is 4. If you differentiate 4x plus 1, you get 4. So there's your answer there. So it can be written like that, or you can write it as 1/4 e to the 4x plus 1 plus c. Okay, finally then, h. So we've got the integral of 1 over the root, the fourth root of 2 plus 5x with respect to x. Okay. Now, thinking about this now, we've seen lots of different rules we use. Think about what sort of rule we need to use here. And actually, this just goes back to the first rule, doesn't it? Because we've got a linear term here. This can be written as a bracket. Okay, if you want to start with, you could write that as 1 over as a bracket. Well, the fourth root, which is just bracket to the power quarter, yeah? Okay, and of course when you integrate it, you need to take it up. Okay, so minus power, and then we can integrate it just like we did before. So when we integrate this then, well, you don't forget then you add 1 to the power, so minus a quarter. If I add 1 to minus a quarter, I get 3/4. Divide then by this power, which is 3/4, and times by the derivative in here. Well, it's what's in front of the x, so that's 5, plus then the constant at the end. So on the bottom you get 15 over 4. Okay, because 3/4 times 5 is going to be 15 over 4. And of course, because you divide by a fraction, then what you can do is take that bottom number up, yeah? So it flips up to the top, so you get 4 bracket 2 plus 5x power 3/4 all over 15. Or if you want, you could just put 4/15. Just do it like that. Plus your constant.